In this lecture, we will discuss addition of acetylide ion on carbonyl compounds. This molecule is called acetylene. If I remove one H plus from this molecule, we will have a carbon ion, and this is called acetylide. Acetylide can act as a strong base or a strong nucleophile. It can act as a strong base or it can act as a strong nucleophile. With carbonyl compound, it acts as a strong nucleophile. If you see a carbonyl compound, oxygen is more electronegative, so it will have delta negative charge. Carbon will have delta positive charge. So there is electron shift from carbon to oxygen side. So a nucleophile can attack on this carbon. So what happens when acetylide ion attacks on this carbonylic carbon? This opens and this gives alkoxide ion. So this ion is alkoxide ion. So this is first step, that is SN2 kind of reaction, nucleophilic attack. Nucleophilic attack. Now next step we have protonation, that is now this alkoxide ion if reacted with acid, it gets protonated to give final alcohol as a product. Let us discuss reaction of acetylide ion with different kind of carbonyl compound. First is with formaldehyde, HCHO. So when it reacts with formaldehyde, this will attack, this opens, so we will have R, C triple bond C, O minus. Now when they protonate this one, this becomes CH2OH. So this gives a primary alcohol. So formaldehyde gives primary alcohol or 1 degree alcohol. Aldehyde but not formaldehyde. So let us say with aldehyde of this kind, R dash CHO. In this case again, we will have nucleophilic attack of this carbon ion. First we will have addition product, and if this gets protonated, that is we require acid, we will have finally an alcohol, and this alcohol is 2 degree alcohol, that is secondary alcohol. So you see this carbon is attached to this carbon, and this side we also have a carbon. Now when acetylide ion reacts with ketone, so let us say we have a ketone, this attacks, this opens, then we will have R dash, R double dash. If we do protonation, finally we will have a 3-degree alcohol this time. Now let us discuss this problem. So question says, so how you would synthesize the following compound beginning with acetylene and any necessary additional reagents. So you have to prepare this compound from acetylene. If we do retrosynthesis analysis, that is if we look backward, we can clearly see this is acetylene molecule. So we have to add this part of molecule and we have to add this part of molecule. So let us first try to add this one. So what we can do, we can take acetylene, and if acetylene is treated with NaNH2, initially it will form acetylide ion. Now if this acetylide ion is treated with alkyl halide CH3CH2Br, nucleophilic attack will take place and this will give CH triple bond C CH2CH3. So we have added this part of molecule. Now we have to add this one. So what we can do, we can make acetylide ion again. So let us say we have CH3 CH2C triple bond C H. If I treat with NaNH2, we will again generate acetylide ion. Now this acetylide ion, now it will act as a nucleophile. So we need corresponding carbonyl compound. So I can take carbonyl compound of this. So 5-membered ring. And if I take this carbonyl compound, you see this is a 1, 2. So this is a 2-degree alcohol. So this means I have to take aldehyde. So we cannot take this one. This is a ketone. So we have to take an aldehyde. This means I have to take this one because I need one extra carbon also. So I need a aldehyde that contains aldehyde group on side chain. So if this compound is treated with this acetylide ion, this acetylide ion will attack on this carbon, this will open. So we will have CO minus hydrogen C triple bond C CH2CH3. Now we do protonation, that is if we add H plus, we will have COH H C triple bond C CH2CH3. So this is the desired compound we need. That is, I need a 5 carbon COHH, 5 carbon COHH, and then we have C triple bond CH2CH3. So what we have done, so first we have reacted acetylide ion with alkyl halide, and the second step, reacted acetylide ion with ketone. So first time this alkyl halide is reacting with alkyl halide, second time this is reacting with ketone to give this final product. So this is a 2-degree alcohol. So this is aldehyde, sorry, this is not ketone. So second time it is reacting with aldehyde, and that's why it gives 2-degree alcohol. So this one is aldehyde. Aldehyde gives 2-degree alcohol.